Hello. In this video, I'll talk about Lab 2, Lines of Charge, in which we attempt to quantify the charge of a tape using a computational model. The objective of this lab was to quantify the charge of a piece of tape using a computational model we made in Glowscript. Some important equations and constants we'll be using in this lab can be seen below. In this lab, we collected data for two positively charged tapes using the same process as in Lab 1, and that we made two positively charged tapes and then measured the distance traveled by one of the tapes when we placed one of the positively charged tapes beneath the other positively charged tape. We then used this collected data to build a computational model which simulates the tape as a line of charge and can then calculate the charge of the tape B. Two important assumptions during this lab were that the two tapes have the same magnitude of charge, and that the charge is distributed evenly across the length of the tape. In the actual experiment, tape B had a length of 0.193 meters and a width of 0.019 meters. We then used a few assumptions to determine that tape B has a mass of about 0.000193 kilograms. During the actual experiment, we determined that tape B traveled 0.016 meters after being repelled by tape A. Also important to this experiment is Newton's third law, which implies that the net force when tape B is floating is zero, meaning that the electric force in tape B is equal to the negative gravitational force felt by tape B. By performing a few calculations, we found the force on the tape due to gravity to be negative 0.001891 newtons. Therefore, the force on the tape due to the electric field from tape A is 0.001891 newtons. Finally, using these previous calculations, we were able to determine that the charge of tape B is 7.33484 times 10 to the negative 9 coulombs. It is known that regardless if the tape is treated as a line or point charge, the gravitational force acting on the tape remains constant. We can therefore assume that the gravitational force acting on this tape remains to be negative 0.001891 newtons. We have therefore used a computational model to calculate the amount of charge present on tape B when the magnitude of the electric force equals the magnitude of the gravitational force. We did this by guessing and checking the magnitude of the electric force while changing the charge of the actual tape. After doing this, we are able to determine that when treating tape B as a line charge, the charge of the tape is 1.92654 times 10 to the negative 8 coulombs. This resulted in an electric force of 0.00189 newtons, as expected. On this slide, you can see the start of my Glowscript code, in which I have my constants and also the function I made to calculate the electric field, and on the right, the function used to create the line of charge. On this slide, you can see more of my Glowscript code, particularly code I used to form my two lines of charge, and also my code for my different scaling factors I used to make my model more readable. This is my final slide of Glowscript code. Up top, you can see how the concept of superposition is used to calculate the net electric fields acting on the observation location. Down below, you can see how the electric force values were calculated and then also how the arrow objects were created. In this slide, you can see the Glowscript model developed using the charge value, which was estimated in Lab 1. This charge value results in a very small electric force vector and small electric field vectors, showing that this charge value isn't very realistic when treating tape B as a line of charge. In this slide, you can see the Glowscript model developed using the charge value estimated via the computational model. This charge value results in an electric force vector equal in magnitude to the gravitational force vector, showing that this charge value is quite realistic when treating tape B as a line of charge. To summarize, we calculated the charge of tape B when modeled as a point charge to be 7.33484 times 10 to the negative 9 coulombs, whereas we calculated the charge of tape B when modeled as a line charge to be 1.92654 times 10 to the negative 8 coulombs. These estimates are different due to the different assumptions made while calculating the charge of the tape. When treating the tape as a line of charge, the net electric field at the observation location is calculated by integrating across the line of charge. When treating the tape as a point charge, however, the net electric field is determined via one simplistic electric field calculation. The charge estimated when treating the tape as a line of charge is likely more accurate, as this is similar to how a charge is actually distributed across a piece of tape.